So yeah, we've probably seen this picture before, but I showed it to you before, and there's loads of similar looking pictures. So just take that circle, just stare at it, and I'll pause the video. 7, 6, 5, 4, 3, 2, 1. Hopefully you found that she looked all in colour at that point. All right, well, why did that happen then? Well, it's to do with, at the back of your eye you have these, where have we got? At the back of your eye we know we've got the retina here, and in the retina we have cones and rods. Now your cones are the ones that are responsible for colour. They're sensitive to particular wavelengths of light. And as you can see, the blue cone is sensitive to this colour, the green cone is sensitive to that colour, the red cone is sensitive to that colour. Now what happens if you're, in fact I'll demonstrate it a little bit more with this image here. So we've got this colour here, it looks like magenta, more or less. I think it doesn't really look like magenta actually. Let's find a better one. It's about the closest to magenta we can get actually for now. We'll just say that's magenta. Yeah. And what we'll do is we'll make that one white for the moment. So if you stare, this one is a much simpler version. If you stare at this magenta square for a moment, I'll pause again. We'll pause the video again. 3, 2, 1, and delete. So you should have seen a square that was roughly the colour of this green. Now, without going into too much detail in this short video, we can use this as a kind of, how much detail shall I go into? Well, basically imagine that these are 3 spotlights, a blue spotlight, a red spotlight, and a green spotlight. The other colours are just when the spotlights have intersected. So strangely enough, when you get a red spotlight and a green spotlight, what this is telling you is that you get yellow. When you get a red and a blue mixed together, you get magenta, and you get a blue and green, you get cyan. And when you mix them all together, you get white light. This is not how we are used to mixing colours. It doesn't work like that when you mix paint, but we're not mixing paint, we're mixing light, and they follow different rules. So basically, white light is a mixture of all of the colours. So when we looked at the white light, we are essentially getting the red, blue, and the green light coming together at once in our eyes. However, while we're looking at this, the magenta was a combination of the red and the blue. So all of our cone cells that were focused on this, was absorbing all this magenta light. Well, the red cones and the blue cones were kind of doing a lot of work, while the green cones had a rest. The green cones weren't really doing anything, and the green cones, really a better way to think about it is the green cones were getting more and more sensitive, trying to detect some green light, whereas the red and blue cones were actually reducing sensitivity because they were getting loads of blue light. So when you delete it, and suddenly all those cones are getting the red, blue, and the green lights, which are coming from the red, blue, and green LEDs on this monitor, whichever monitor you're looking at, and then what's going to happen then is the red and the blue light is not going to be detected as strongly as the green light, because the green cones have had a bit of a rest, and the red and blue ones have been working quite hard. So essentially that's what's going on in every single pixel in this picture here. Okay, there's a variety of different colors, and you can see her hair is kind of whitish, or so I imagine when you see the opposite of that, it's going to be darkish, like blackish or brownish perhaps. And the rest of the color, you can see these are sort of bluish, or what's the opposite of blue? Well, yellow. So it's not completely blue. She doesn't have yellow skin, but basically what it's a combination of all these different colours, and it's obviously a lot more complicated than what I've just demonstrated there. But this is why this is a negative. A negative is essentially using the opposites, opposite colours. So it tires out the cones of that particular colour. So the rest of the cones are actually more active and they can detect it more strongly. So I don't know if I explained that well enough, but that gives you a gist of it. But also have a look at all the other stuff that we did, and we made a couple of other videos around this as well, which kind of gets at it. But yeah.